Welcome to Electronic Device and Circuit Group Assignment 1 by Group 3. Here we have the circuit designing phase. Firstly, we get Tinkercad up and running and open a new document and place a breadboard as shown. We can also then grab a function generator and place it right next to the breadboard, as that's what we'll be using to generate the AC current needed for this project. And then set the frequency to 50 Hz, the amplitude to 10 volts, and the DC offset to 0 volts. The function can also be set as sine instead of square. And also then start building the bridge circuit, which is made using 4 diodes. For our project, we have used a bridge rectifier where the peak output voltage will be equal to the peak input voltage after subtracting the knee voltage of a diode. We then can place a Zener diode and build the Zener circuit, which acts as a voltage regulator in this project. We then can build the filter circuit using a capacitor, which is used to smoothen the output voltage. We then can place two resistors needed to build the filter and voltage regulator circuits, where one is a 500 ohm resistor and the other is a 1 kilo ohm resistor. We can then start making the connections between each of the components to complete the circuit needed for this project. We can now start connecting the positive and negative terminals from the function generator to the positive and negative terminals on the breadboard. After that, we can start placing the oscilloscopes needed to get the output and readings of the circuit. We can also set the time per division for each oscilloscope as 5 milliseconds to get a better output. We can also then start making the positive and negative connections for each respective oscilloscope to the circuit to get our desired output. Now, as you can see, the circuit is completed as per design. The value of the capacitor is then changed to 250 microfarads. And now we can move on to the simulation phase. Function generator is then set to a frequency of 50 Hz, an amplitude of 10 volts, and a DC offset of 0 volts, and a function of sine. And once the simulation is run, as you can see, the desired output is attained of almost a straight line. After you are done taking the required amount of readings, you can then end the simulation. And that's all from us of Group 3 from Section 10. Thank you.